Hi everyone, I am Sid Gambhir from Accenture's AWS practice. I have a colleague here, Enno.
So I'm Enno from Accenture Industry X, and I'm leading the manufacturing operations for the German-speaking market at Accenture.
Very good. I support our partnership team with AWS, focusing on automotive and manufacturing as industry verticals. Happy to be here at Hannover and talking to you all at the AWS Theater. Today, we have a very, very exciting client value story to present to you, where we worked with AWS and we worked with a client to really prove out a concept of using generative AI in the manufacturing space. And the use case here was to improve machine uptime. We will go into the details of the use case as we go through the presentation, but first we will just do some context setting in terms of what we see in the automotive and manufacturing space. When it comes to Industry 4.0 or digital manufacturing, we have seen our customers, our clients across automotive and manufacturing really go through a lot of period of complexity with their customers asking for more and diverse types of services. At the same time, supply chains becoming more and more complex, and customers that are demanding highly personalized products and services, and production that should be done in a sustainable fashion. At the same time, automotive and manufacturing companies have already harvested a lot of low-hanging fruit use cases. They have done a lot of POCs, they have done a lot of pilots, small-scale projects, and now are facing the need to go scale up to end-to-end autonomous operations. In fact, in a recent Accenture survey done last year, there was a data point that 75% of manufacturing managers, and so these are line of business individuals, they confirm the need to reinvent end-to-end operations and manufacturing instead of just applying digital technology to single use cases. So let's take a look at what that actually looks like, in our opinion, reaching an autonomous state of operations. If we think about how the core value chain is done today for automotive and manufacturing companies, everything is done kind of in a sequential manner, in a siloed manner. You have your product engineering, supply chain, production, quality, inventory. All the data is pretty much siloed. Planning is done based on historical data that may not really fit the current demand or the future demand. Execution is done using very static process, in a process-oriented manner. There isn't the right capability in place to learn and quickly react to immediate challenges or what's happening on the plant floor. In our opinion, the future really is end-to-end autonomous operations powered by AI and generative AI. And what some of that means is data-driven intelligent planning, where you're looking at not just the historical patterns, but also looking at current demand and how that's dynamically changing. In the execution on the plant floor, AI systems and intelligent systems that provide guidance on next best things, not just reporting and visibility, because frankly that is already there, but also understanding of the causal relationship between assets, manufacturing processes, and being able to recommend the next best action. And finally, tightly integrated data flows between the planning step, the manufacturing execution step, and continuous improvement, so you can get a single view of your plant across quality, across production, across inventory, etc., and make multi-variable optimization decisions. But this is a big sort of nirvana state. How do you actually get there? What are some of the small steps required in order to get to this autonomous operation state? That is what we are here to talk to you about today. In our opinion, this is not just achieving autonomous operations. It's not just about solving for a technology or using a cloud. It's about an end-to-end transformation of defining a strategic roadmap that is really focused on value and the right capabilities required to accelerate time to value. From a operations perspective, it's about re-establishing a data-driven culture and a human plus machine in the loop kind of an operation where the human is learning from the machine and vice versa. You're not totally disconnecting those two facets of manufacturing execution. So you need to reinvent training, culture, enablement of the human to use the machine and vice versa. And then finally, defining and implementing a data-driven architecture that can scale to support digitization of manufacturing data and the multiple use cases that can sit on top. Today, since we're in the AWS booth and given our time limitation, we will talk about the third topic, which is establishing, defining and implementing a twin-based architecture and how to scale that using one use case at a time. And simply put, there are three objectives for that. Defining, making the data accessible so that you can actually train the AI systems and train the AI models, understanding the context in the data, and evolving the manufacturing architecture to be data-driven in nature. And then thirdly, being very ecosystem-oriented, and that's why we are here at the AWS booth. We will talk about the role AWS played in this client value story as well. So to bring this to life, in our opinion, how can AI and generative AI be used to change how manufacturing and operations is done today? And it's really about getting human-centric insight that can take many shapes and forms. I will just cover 4 examples here today. Building and deploying digital twins that facilitate better performance analysis, what-if analysis or simulations on your manufacturing floor. AI agents that can analyze data, recommend steps based on the human intelligence used to develop the AI agents, so better informed decision making, improving machine uptime through predictions of certain events that happen on the manufacturing floor, and then sort of a future-oriented capability to have multi-agent systems, even in manufacturing, recommending in real time, orchestrating workflows to improve overall operations. Once again, this is the North Star, this is the future. What we will talk about next is a specific use case and an example that we implemented with an automotive supplier here in Germany of using industrial IoT, AWS cloud, but also generative AI to make real tangible improvements in how they do operations. I will hand off to Enno to cover this wonderful story.
Thank you very much, Sid. Becoming autonomous means you need to take decisions and implement actions afterwards. So as humans, we do that all the time,
yeah,
right? But taking the right decisions and the right action very much relies on you need to have information. Information comes from data and context. Then from the information with the context, you need to generate insights. And then we have the foundation to do decisions. What we see in a lot of manufacturing plants today is, yes, we have done all this digitization, so we produce a lot of data, but it is not enough to really create insights. So we know that OEE is bad, availability is bad, our machines are not running, but why is that? So the root cause analysis, the why is missing. The question is basically now, what could I do? So the capability to take basically actions or to define potential actions and then really implementing it. So basically, we are very much stuck in describing how bad it is, but not in the why, in the what could be done, then what if, and then what is the best option and implement it. Yeah. And so this is actually the starting point for this client example, where we have production lines which are not running optimal, right? So if the availability of individual assets in a line is not there, so you just cannot produce, you lose money. If your quality is not there, basically you basically waste all the things you have in production, material cost, all the work, so it's wasted money. So the question is what to do about it. And this is where actually we come in with knowledge graphs, with generative AI, agentic AI. AI to address that problem. So to find out why something happened in manufacturing, so all that you know from Lean Six Sigma, etc., that's been around for such a long time. You all might know these nice Ishikawa diagrams, the 6 M's of manufacturing. So it could be a problem with the machine, it could be a problem with the material, with the man actually operating it, with measurement, with the method, the production process itself, or the environment, humidity, temperature in the building. So, but what we have today is very much, we look at silo data, we look at machine data, something not working, or we look at the data from the manufacturing execution system, but we never have that basically all together in a context. So the basic step to work on this is actually, how do I get all that things in a relatable manner, so that I really can connect what is happening in the machine with what the machine, what the man has been doing, what basically the manufacturing process was, and the building information. So you need to contextualize data, bring it into a what we call a knowledge graph or semantic layer. So that's one of the really important building blocks. And that technology has been around for years. And I think I'm quite good in doing SQL and database queries. I worked myself into a knowledge graph data science, and it is super horrible as a human to do that. But now comes Gen AI. So if you have all that data in that big graph contextualized, then instead of having a ton of data scientists, you basically just ask your Gen AI agent to query whatever you need to understand the why and to evaluate the options. So we use basically the knowledge graph with Gen AI to make data really available, to create insights, which you then use for decisions. Another topic where it's interesting in these knowledge graphs is structured data from ERP and MES systems and machines. That is quite easy. But what do you do with all that knowledge that is basically in unstructured data? So you have so much information in installation, operations, and maintenance manuals. So how to bring all that textual data and all these images from these manuals and make them accessible for the analysis? And then you have maintenance tickets that people have written all over the world in all different languages. How do you make that accessible? Yeah. And you have quality information. So how do we make all of that accessible? This is also where Gen AI comes in. Now, not from the top, basically, where you use Gen AI basically to be your personal data scientist, but you can take all that unstructured information, text, images, etc., vectorize it and basically move it into the knowledge graph. And then you basically have all the information from all the domains connected, structured and unstructured, independent of what language is it, and you make it accessible. Right? And then the last step that is missing, you need to put it in some kind of user interface, so that basically your co-pilot, that you can work really with that data. And so bringing these things together, knowledge graphs, the Gen AI piece on the top and in the bottom, and a good user interface, that's pretty much what we have done. Right? And I don't want to go through all of that, but that's just to show you a little bit of the graph we have been starting to build. So, in general, a graph is a connection of information elements, and you describe these connections. And yes, we have put in information from equipment. We have put in information from the manufacturing process, and the work instruction, and the manuals, and the maintenance tickets. So we have put it all into that graph and basically all related it together, that you can query it from any dimension. So that's just a little piece of a graph. Imagine you would have completely different cases. You could make that for product development, for supply chain management, so that graph will grow. But if you do it right, you would have one enterprise-wide knowledge graph where you contextualize all your information. So you make all the knowledge you have in your company available, basically on a button press, or even better, on a user interface which you can talk to. And that's what we also implemented, basically a human language interface to all of that basically related information. So that is just a very simple example, which you can do in really no time to visualize that graph, right? So we have here on the top, we have a little bit a picture of the line. No, it has not been the real line from our client. We are not allowed to show it, so it's basically just another picture. But you see all the different stations, they have their status, if it's running okay or not, and you can have everything that you would have in OEE, just very simple. You see the knowledge graph that basically just displays a little picture of how basically the machines are connected and the process, and then you can see basically the information. You can drill down on basically what is the cycle time or PLC error messages, because it's all there. But then making it accessible, we have this nice little user interface. And yes, you can use it via text, you can talk to it in any language. And the benefit of that is it not have only the structured data, but all the data that has been produced in your maintenance departments from your operators worldwide. So if you have similar problems somewhere else, actually it will be immediately accessible. So that is basically a new thing to unlock value of all the data and knowledge you have here in your company. And it's only possible because we have now the combination of, we have the data from digitization, we have the knowledge graphs, which have been around for quite some time, and then we have Gen AI from the top and the bottom, and now this agentic framework, which basically be your data scientists and your analysts basically going through all that relations and answering the questions that you have to improve uptime, to fix machines quicker, to basically analyze the root causes for low yield, etc. So it's an unthinkable power that you get now. So, I think no, it's still.
Yeah, it's good.
So to sum it up, a Gen AI-powered semantic operations twin. If you hear that, you might have thought about this fancy 3D, but it's really the twin of the individual asset on a database. It's a production system, how basically all the assets and entities are connected, the machines, material, people, etc. And then the manufacturing process, and that is basically what we would call a semantic operations twin, and Gen AI actually is powering it. So it reduces the time to query the documentation. It basically gives you much more accuracy in everything that you do. And as said, with this RAG actually retrieving documents and answering questions, that's not 100% yet. But basically the time that you save, you will still have the human in the loop to basically identify and ask another question. So this is actually what speeds up the process. And the nice thing about it, it learns, right? So when you have an operator who has a question, what should I do with my machine, and the Gen AI doesn't answer in the right way, you can have that improvement loop, so next time that the answer is better. And so this is basically a continuous improvement cycle also on that big large language models. So in general, that is the next level of basically operational excellence, be it availability, quality, performance in your factories. So this is now basically available. So I think it's an exciting time ahead of us, taking operations way forward.
Absolutely, making the vision a reality. So this actually concludes our presentation. We are here to take some questions and discussion with you for the next 10 minutes or so. We also have a kiosk in the AWS booth just over there. You can come and talk to us. And the Accenture booth is located in Hall 17 with some more stories that we can showcase there. So thank you for your time and attention. We can take some questions and discussion if there are any.
Hello. What are the role of continuous improvement experts of the past in this digitalization process? Because those digital processes sometimes implemented by the pure IT guys, they don't know, the first pass yield, some Six Sigma, so they have no idea of that. What are the role of the process improvement guys of classical Lean Six Sigma?
So this is a teamwork here. So you need to basically bring that data in a standardized, normalized way together. And so what we there, so it's a topic of data mesh and data products, where the organizations which actually are producing the data should be the ones that describe and basically make sure the data is standardized, normalized, understandable. So the domain owners, basically the machine maintenance department, the production team leads, that will be the people that make sure the data is available, understandable. So to get that data all integrated, so yes, you need data scientists. But in the end, so your Lean Six Sigma experts, these are the ones that have to ask the right questions, right? That have to do the root cause analysis, have to do the correlation, the where is it not, right? So the Lean Six Sigma, Kepner, Trago, all of that will not go away. But if you now look at your Lean Six Sigma teams, how much time they spend basically doing a value stream analysis or basically analyzing quality data, so how much is basically administrative low value at work? Imagine they would have all that information at your fingertip and really could focus on improving operations. So these jobs will not go away, but they will have 10 times more power to really focus on the real value add instead of just doing data collection, clicking in tools, etc. So it's a teamwork.
Thank you.